everyone, it's Alyssa and welcome to You Can Learn Math. Today we're going to talk about synthetic division and the steps we need to do that. Synthetic division of polynomials. Last time, my last video, link in the description below, we talked about long division of polynomials. And that's a topic where a lot of students, usually the reaction is like, oh, this is so tedious. It takes forever. It takes half a page. I hate this. Not an unreasonable response. I admit it. Then we're moving on now to doing the same problems but using synthetic division. And your response is likely to be, why didn't you give this to us sooner? This is so much easier. It is. So here's a problem. I'll show you the fast-forwarded hyper version of it. Yeah, that took a minute. Let's do it using long division and you'll see the difference. So we started with x cubed plus 5x squared minus 32x minus 7. And that was divided by x minus 4. I'm honestly, I'm chuckling to myself. This is so much easier. It's going to blow you away. And I know it looks weird, but what's actually happening, the process of it is so easy. So here's what you do. First things first, you're going to look at what you're dividing into. And you're going to say, what are the coefficients? Now remember, if it's just an x cubed and there's no number in front of it, it's the invisible 1. Because we only have one x cubed. All right, so what are my coefficients? I have a 1 in front of the x cubed, a 5 in front of the x squared, a negative 32 in front of the x, and then a negative 7 all by itself. Next, I'm going to look at this one. Now, you're going to take this number and you're going to write its opposite. If it's negative, write positive. If it's positive, write negative. This is a negative 4, so I'm going to write positive 4. And here comes the fun part. That's my setup. I just took all the coefficients and wrote them down there. And then I took my divisor, that number, and wrote the opposite of it over here. All right, now for the fun part. Step 1. Bring this number down. 1. Now I do 4 times 1, and then I write that here. 4 times 1 is 4. Then I add. 5 plus 4 is 9. Then I multiply. 4 times 9, and I write it here. 4 times 9 is 36. Then I add. Negative 32 plus 36 is 4. 4 times 4 is 16. I write it there. Negative 7 plus 16 is 9. And I'm done. You go, what? What just happened and how are you done? Okay. The last number you get, whatever it is your remainder. Everything else consists or makes up your coefficients, whoa, squeaky chair, for your answer. Now this one began with an x cubed, so you're going to start one exponent, shall we say, lower. So you're going to start with an x squared. So this is my x squared. Then I just go down the line. 9x, 4. My remainder is 9, so if you remember this from the long division of polynomials, you write your remainder as 9 over whatever your divisor was, x minus 4. So x squared plus 9x plus 4 plus 9 over x minus 4. If you get a 0 as the last one, that just means you have no remainder. That is very useful for if they ask a question. You'll see this with synthetic division. They'll say, use synthetic division to determine if this binomial is a factor of this polynomial. For example, here's one. They'll say, okay, determine using long division if x minus 2 is a factor of 6x cubed minus 19x squared plus 16x minus 4. Why this teacher has suddenly become slightly British, I don't know. But here we are. So all they're asking you to do is say, use long division, divide this whole thing by x minus 2. If you get a remainder of 0, it's a factor. Just think about it like in normal, I say normal, in your sort of old school, original elementary school math. Is 7 a factor of 56? 7 goes into 56 8 times, and there is no remainder. Yes, 7 is a factor of 56. That's all we're doing when we say, is it a factor? Is divide it. Is there a remainder? Then if there's no remainder, it's a factor. Excuse me. Okay, so I write down my coefficients. 6 from the x cubed, negative 19 from the x squared, 16 from the x, negative 4. And I go, okay, I write the opposite, positive 2. And I do my little math. I bring down the 6. 2 times 6 is 12. I add. 2 times negative 7 is negative 14. I add. 2 times 2 is 4. I add. Woo! Remainder of 0. I don't actually have to do anything else for this particular question. They're just asking, is it a factor? Remainder is 0, so yes, it is. There are only a couple little tricks to remember with synthetic division. This is the biggest one right here, is let's say, and I'm just making this up off the top of my head, so I have no idea if this will divide prettily or nicely. But let's say I had something like 7x to the 4th plus 2x squared plus x minus 1, and I wanted to divide that whole thing by x minus 4. Again, no idea how this is going to turn out. You may notice there is an x to the 4th. There is an x squared. There is no x cubed. You have to have, when you're doing our little thing, you have to have something once you've started for every exponent going all the way down. Because I've started at an x to the 4th, I have to write something for x cubed. If there's not an x cubed, write a 0. If there's not an x squared, write a 0. If there's any one of these things that's missing, put in a 0. If it just ended at x, then put in a 0 for that constant on the end. Just always do that. So there's our 7x to the 4th, no x cubes, so 0. 2x squareds, 1x, and then a negative 1 is my constant. I write the opposite is 4. And then I go through my process. Bring down a 7. 4 times 7 is 28. Oh, this is going to be nasty. Bring down the 28. 4 times 28, what is that, 112? 112 plus 2 is 114. Oh, I made this bad for myself, didn't I? 4 times 114 is 456, I believe. Shoo-wee. Oh, I regret this. I regret this so much. 457. 4 times 457. Okay. 1,828, I think. Wow, I'm going to have to check this with the calculator afterwards. I'm going to be so embarrassed if I got that all wrong. All right. So what this would mean is my answer would be 7x, we start one lower, cubed, plus 28x squared, plus 114x, plus 457, plus a remainder of 1,827 all over x minus 4. This is what happens, kids, when you just pick something randomly and don't use a problem that you prepared beforehand. The only sort of hiccup you might encounter, and this is unlikely when they're first introducing you introducing you to, excuse me, synthetic division, but I'm just going to throw it out here just in case, is if you have something like, say, 2x cubed plus x squared minus 17x plus 5, and they want you to divide that by 2x minus 5. As you might notice, this is a 2 here. It's not just the x minus 5 or x plus 4, things like that we did before. When that happens, what you do is you say, okay, 2x minus 5. I need this just to be a plain x plus or minus something. So I'm going to divide everything here by 2 so that 2 is not there anymore. So what that gives you is x minus 5 halves. Is that annoying that now you have to work with fractions? Yes. Yes, it is, but it is what it is. So there we are. And then you go through the same process that you did before. You write down your coefficients. Here we have a 2x cubed. For x squared we have 1. For x we have negative 17. For the constant we have 5. And we write the opposite, 5 halves. Okay. Just put that over here, x minus 5 halves. Okay, so I do my same steps. I bring down my 2. 5 halves times 2 is 5. 1 plus 5 is 6. 5 halves times 6 is 30 halves, or 15. Negative 17 plus 15 is negative 2. 5 halves times negative 2 is negative 5. 5 plus negative 5 is 0. So this one, again, we go one below what our x cubed was, so it's 2x squared plus 6x minus 2, remainder of 0. If we did get a remainder, just one final thing, you get a remainder something like, let's say if this had been like a remainder of 6, and you're like, okay, 6 over x minus 5 halves, we don't want that. We want it to look like this, our original thing. So what you do is you would multiply it by that same coefficient over itself, because 2 over 2 is just 1. To get rid of this fraction and get it back to that 2x minus 5, you divide it by 2. Now you need to multiply by 2, but you're going to multiply the top and the bottom by 2, since 2 over 2 is just 1. So in that case, you would get back to the remainder. It would be, in this hypothetical problem, 12 over 2x minus 5. Again, if you had a remainder for these kind of problems, that's how you get it to go back to looking like that. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.